Hello students, a very warm welcome once again to all of you. So, now it is question number 73. Well, we tried our best to combine the questions in a compact format, and also very carefully we decided the type of questions, so that after you can say going through with these around 90 plus questions, you can be sure at least around 10 to 12 questions you are getting from these type of collections. It's an effort from our side. I don't know how much it's going to be useful for you, but it's a suggestion from our side. Please take a look of these questions slightly carefully. Fine. So, what is this question? This question is associated with a motion of a conducting material object in you can say external magnetic field. What is the question? It is a type of statement. You have to justify or say yes or no type of statement, and also you have to justify. Justify means simply you cannot say no or yes for 3-mark question. You have to explain it also. Will an induced current develop in a conductor moved in a direction parallel to magnetic field? So, first thing, why I picked this question? Actually, this question in itself is not very you can say self-explanatory. Will an induced current develop? Okay. So, question ended over here like this. Is it possible that the induced current will come up, will be generated when in a conductor moved in a direction parallel to magnetic field? So, let us try to understand first the question, then we will go for the answer. Actually, this is the symbol of the magnetic field perpendicular to this green board inside. Means magnetic field lines are going like this, and this is the magnetic field direction perpendicular to this green board outside. Nice. Now, if any conducting material object, say for example this blue color chalk holder, imagine it is made up of gold conductor, iron, copper, silver, it is moving like this or like this. In this scenario, magnetic field lines are perpendicular to its direction of motion. Fine. But in this particular statement, it is said parallel to magnetic field lines. So, parallel means either this blue color chalk holder is moving like this, please try to imagine, or moving like this. Fine. Now, in this scenario, there are two possibilities to say that the change in flux will not take place. How? So, first I will write down simple statement about this question, then I will also explain further, so that if any correlated question is asked, you can answer it properly. Fine. What is that? That is no induced current will appear across the conductor because BECA complete, not SMS language, because across the conductor, because no EMF is developed. This statement is the answer, but you may say, sir, this is not complete. Well, we are not getting the feeling that it is proper answer. As no flux change is taking place. Fine, but still you may say, sir, we are not getting the fragrance of that particular technical aspect. Fine. Well, phi b is equal to b a. Fine. Now, imagine the situation. When it is moving parallel to the magnetic field lines, is there any type of flux change is taking place? Because the concept of area is meaningless over here. So, it is going to be BLB type of situation. Because the motion is in the parallel direction of the magnetic field lines, so no flux change is taking place. So, as no flux change is taking place, therefore, no EMF will appear, and because no EMF is there, so therefore, no induced current is going to come up into the conductor. Now, why I devoted this much time on this particular question? Reason is simple. See, it is not like that I should write down only 2-3 words of the answer. I have to give you the proper idea. Fine. So that if some correlated question is asked, you can properly answer it also. So, this question is from EMI, electromagnetic induction, and this is the very interesting, useful, practically useful, because all these lights are present in front of me in this studio. The camera is functioning because of the electromagnetic induction flux change process. Fine. After this, next question 74. This is again from the same situation, electromagnetic induction, but here I explained 2 types of situations. First is, calculate the rate at which the flux linked with the generated area changes with time when there are 2 cases. When a rod of length L, this is you can say case 1, fine, L is translated means moving like this. So, there will be 2 components, like this is a rod and it is moving like this, somehow like this. B, rotated means now this white color tip is fixed and then it is moving like this, fine, circular motion. So, there are 2 cases with the same rod. So, what I will do, I will explain. It is a very beautiful example and most sought after example. Because in general, not only in your board exams, but also in your competitive exams, there is a very good probability that the question based upon this concept must be asked. This derivation we have discussed during the discussion of our, you can say, regular courses, and also this relation. So, let it be over here, fine. Let us take a look of the question. I am out of your frame, freeze it, read it, think it, then I am coming into picture. So, some portion it may be. Now, velocity, just take a look of A, this is A part, velocity perpendicular to the rod, perpendicular to the rod. I'll explain you, don't worry, but first listen it. V sin theta, fine. What is the meaning of this? Please come over here with me in this diagram. This is velocity. Velocity is not in horizontal direction, velocity is not in vertical direction. So, there will be 2 components, V parallel, that is V cos theta, V perpendicular, that is V sin theta, fine. So, I mentioned like this, please come over here, you can still take a look of this diagram. Then V perpendicular is V sin theta. Then what is essential for electromagnetic induction? Area vector. So, and it is moving for some time, say for example t. T is the time for which it is moving. Area covered in time t. Actually, this question is not a numerical problem. This is a concept discussion. Numerical can be prepared on this basis. Theoretical question also can be prepared on this basis. So, this is just a concept discussion, and you can put this question in the category of HOTS, high order thinking skill, HOTS, hot question, fine. So, area covered in time t is equal to how much? It is going to be, what is the length? Length is given is L, L into V sin theta into t. L V sin theta into t, yes, correct. So, now phi is equal to B L B, because rod is in motion. So, B L B T sin theta. Now, this expression, well, I think I should use this blue color chalk. This expression is important, fine. B L B sin theta, we have studied this relation. B L B T sin theta is because of the area d phi b by dt, that is what? Rate of flux change. So, d phi by dt is equal to B L B sin theta. So, I hope this first part is clear, fine. Linked with the rate at which the flux linked with the generated area changes. So, you can say in case 1 the flux with which the area is changing is given by this. So, there are two important aspects. If you can reach till this stage, go through, fine, you are comfortable. After that, it is time for second part, B part. Now, take a look of this B part first. Actually, L is the radius, and this rod is moving like this. So, area is this circular area, first thing we have to find out, and circular area of this circle is going to be what? Okay. So, let us consider this. Area swept by the rotating rod, area swept by the rotating rod, A is equal to pi L square, pi r square, and r is the L. So, it is going to be pi L square. This implies that A is equal to 1 by 2 L square theta. How? Where is blue color chalk? Problem creating blue color chalk. Fine. Now, phi is equal to 1 by 2 BL square theta. ठीक. Now, after this, in previous example, flux change was d phi b by dt. In this scenario, is it like the time change you can find out, calculate? Ultimately, you have to consider the change in this angle theta, and it starts from, say for example, 0 degree and it goes to 360 degrees. So, here in this time, flux change d phi b by dt is given by how? That is 1 by 2 b L square and some amount of jumping omega. How? Okay, wait. few of you may say, sir, what is this? So, when we apply this logic over here, that one, what will happen? Let me enjoy my explanation. Is equal to B L square, name of this person is omega, fine. That is the solution of this particular question. So, it is not a difficult question, but it was like forcing you to you can say visualize properly. Then comes question number 75. What features of electromagnetic waves led Maxwell to conclude that light itself is electromagnetic wave? Actually, they want to know in this question whether you have studied this chapter electromagnetic waves properly or not. Now, many students will start writing like this thing, like what you can say displacement current concept with drawing the capacitor diagram and so on and so forth. Actually, it is a 2-mark question, fine. I not mentioned it, but it is a 2-mark question. So, here you have to mention that theme which is mentioned in your book. Obviously, we were not present at the time of Maxwell. So, you have to mention that theme on the basis of which this entire conclusion has been taken out. And the theme was, people, I mean scientists at that point of time were aware you can say with the basic properties of light. And Einstein found, Maxwell, I am extremely sorry, Maxwell found that many properties present in light which is visible are common in EM waves, fine. So, that is why he concluded that light itself is electromagnetic wave. If I have like this body structure, someone else, an alien is coming for example, has the same body structure. So, what you will conclude? Well, this person is similar to human beings. So, that was the idea of this, fine. Let us consider it. In case of light, electric vector E and magnetic vector B, fine. In case of light, electric vector E and magnetic vector B are playing important role. I am not going to emphasize what exactly the role is, you all are aware. Important role, and out of this try to recall electric vector is really playing very important role, fine. So, on the basis of the analysis of electromagnetic waves, Maxwell also found that this and this is important parameters for the light. So, light, that is why he concluded that light is also an you can say member of electromagnetic waves family. So, it was basically associated with electric and magnetic vectors, fine. I am not going into that much details because it is a very you can say simple type of question, and these type of questions are placed in the question paper just to ease out stress from your mind, so that you can tackle next difficult questions with more happiness. After that, where is the remote? Yes, it is. It is question number 76. Now, if you were driving a car, what type of mirror would you prefer to use for observing traffic at your back? Suddenly, from electromagnetic waves, we reached in the world of what? We reached in the world of optics, ray optics. 3 marks, ray optics. Fine. Well, students, during the driving of a car, there are two types of mirrors, and in bikes there is only one type of mirror on the both handles. There are two whiskers in a car, because the question is about a car. Fine. So, I would like to emphasize only on car. So, two whiskers, they are of different nature mirror, and one is you can say mirror just above the head of the driver inside the car, that is of the different type of mirror. So, the question is, if you were driving a car, what type of mirror would you prefer to use for observing traffic at your back? So, I am slightly confused with this question. Reason is, which mirror, inside one or outside one? Fine. After a lot of thinking, I thought they are talking about these two whiskers. So, let us answer the question, because that is more technical. So, what exactly the answer is? We will use convex mirror. We will use convex mirror. Now, reason is why? Because I think I should write down with because, then I have to put a comma over here. We will use convex mirror because it has large, not large, large is not sufficient word, it has much larger, oh that is great, much larger field of view. Fine. This is one aspect. There are other reasons also. Well, another reason is, I think I should mention that point over here. This is one reason. Another reason is nature of image not changes with distance. Nature of image not changes with distance, that is another property. One or more two properties also. What is the nature of image? Image is always virtual, comma, erect and smaller in size. Fine. So, this is the proper answer of this particular question. That is why on this mirror it is mentioned, objects appear in the mirror are closer than they appear. So, if you are driving a car, I hope in class 12th students get the license or learning license like this. So, if you are driving a vehicle, be always careful. Do not decide your left right motion just on the basis of the observation in these two whiskers. They are called as whiskers. Fine. This question has some practical uses important for your day to day life, and that is why I picked this question. My message was to just think on each and every aspect. Fine. And finally, you can say we are moving in the world of ray optics, wave optics and so on. So, let us enjoy. Establish mirror formula in case of a convex mirror, state the sign conventions used. Well, it is a 5 marks question. Obviously, I will not draw the entire explain the entire thing, but what you should do that I will mention. First thing, few things I will do, remaining you should consider as a message. First thing is draw neat diagram. It is a ray optics. So, each and every point, each and every ray, everything should be clear. So, use a sharp pencil and scale and then draw a neat diagram. Mention each point properly. That is important, like ray AB is going, meeting at point C with the mirror, then reflecting back, meeting with the principal axis or focus at point F, something like that. So, each and every point. Then derivation. Fine. So, I will do a few steps for you. You just take a look of these things. This is the approach for these type of questions. I will do few steps for you and remaining obviously you have to work out. So, now first thing is image formed by this mirror, mirror. I think I should mention this point over here. Image formed by mirror is always virtual and erect. Fine. Next point is, say for example, I am just giving you an idea how you should draw a diagram. Fine. And from here take the object like this. This is the object, point B, point A. So, mention the name like this. Do not mention like it is A, over here it is B. No, it is not the way. Fine. Then show the rays with, if possible and if it is allowed, I hope it is allowed, use different colors pencils. Fine. Ray number 1, always mention the arrow, because moment you will skip the arrow direction, it is going to create a problem. Fine. From here dotted lines backward, where it is meeting it is F, focus. Next ray will start from here, will go to this point like this. Fine. And it moves like this. Fine. So, it is going to be point P, this point is P, okay, this point is P. Another ray will keep on moving and will reach over here, but before that you have to draw back this line. Fine. And wherever it is meeting like this, this is your image. So, name of the image is A prime, B prime. Then you have to allow a ray from here to this point, that is okay. So, this is one aspect, and this ray is also moving onto the same track, same path. Fine. After this a nomenclature is required. So, for example, this ray will meet the principal axis at center, fine, C. Then give the name like this point. Students, for this you should use different color pencil, it is F. Please take a look, from here to here it is V. Then from here to here it is what? U. Everyone just consider. Fine. So, now you have U, you have V, you have F, f point and all this. So, write down like this, AB upon A prime B prime is equal to CB, yes, upon CB prime, and this is true for triangle ABC and ABC and triangle A prime B prime C. Fine. So, this way you have to draw the diagram, and this way from the diagram you should start writing the solution like this, and finally you can reach the result 1 upon V plus 1 upon U, 1 upon V U plus 1 upon V is equal to 2 by R is equal to 1 by F. So, this is the approach for these type of questions. And one more thing, if in these type of questions you are not very much comfortable, then at least draw the diagram very neat and clean. If you are unable to recall so many steps, mention at least explanation of the particular diagram, that is very important. Then comes next question 78. Why does the rising sun appears oval shape? Now, you can say this question is from class 10th onwards, but here it is useful, important question, because it checks your fundamental understanding of this particular concept. I will mention just 1 or 2 points over here, I hope it will give you the clarity. So, why does it appears like this? First point is, this is the question, take a look, I am out, fine, then I am writing few points. Light from rising sun, light from rising sun reaches obliquely, fine, through the atmosphere, fine, through the atmosphere, first point. Second point, you can say vertical dia, because the shape of the earth is like this, sun is rising over here. So, one is vertical dia, one is horizontal diameter, fine. So, we are interested to talk in those terms. Vertical dia appears shorter, while horizontal dia appears bigger. So, this is the cause why we are you can say getting the shape of the rising sun in the form of a oval, like somehow like this, not like this, fine, not like circle. Then I hope we can discuss one or two more questions. So, let us move for this next question. It is a numerical problem, fine, from optics itself. First, take a look of the problem, then I will explain. An air bubble in a glass sphere, okay. Air bubble in a glass sphere, well, it should be like this way. It is a glass sphere and there is air bubble over here, fine. So, there is one air bubble in a glass sphere mu is equal to 1.5 of glass, not air bubble, is situated at a distance 3 centimeter from a convex surface of dia 10 centimeter. So, situation of this bubble is given. At what distance from the surface will the bubble appear? So, obviously, when I look into the bubble like this, fine, it's not going to be like that I will notice it where exactly it is. Consider the case of fish in water. If you are visiting any river and you will notice a fish, it is not like that it is actually at the same position visible to my eyes at where actually it is. So, this is the idea of this particular question, basic formula based question. Let me allow to write down, just take a look of the question, freeze it, fine, I am out your frame, and then how you should solve it. As refraction is taking from denser, although I should not mention it, but denser to rarer medium, fine. Therefore, minus mu 2 by u, fine, mu 2 is for this first medium, mu 1 by v is equal to mu 1 minus mu 2 by r, fine. Now, if you put the values over here, you will get 1 upon v, yes, 1 upon v is equal to, you have to find out the value of v, is equal to 1 by 10 minus 1 by 2. 10 to the 20, 20 minus 10, that is going to give you minus 4 by 10. So, v is equal to minus 2.5 centimeter is the location where this this air bubble is going to be visible. So, we think we should stop over here, and in next set of questions we will discuss further questions, fine, starting away from this particular numbers. So, till then take a revision of these questions. Have a nice time.